Hey everyone, happy Friday. It's Mr. Ekstrom teaching you about inscribed angles today. And I don't know, they're kind of fun, and you can make all kinds of neat designs and logos especially with a combination of inscribed angles and central angles. So in pink here we have our old material that you learned last week, and I guess we used on Wednesday, central angles. And, if I told you that this was 62 degrees here, you'd also know that this arc out here, this little piece of the circumference, is also 62 degrees, right? So central and the arc are the same. And today we're going to find out, in blue, that if we pull this guy back all the way to the circle to point Q, that this angle, the inscribed angle, is 31 degrees. A very convenient fact. The inscribed angle is half the central angle. That is the entire lesson. But we're going to put your brain to the test today with some circles and angle puzzles to apply this one idea. So just say it 3 times. This inscribed angle is half the central angle. Now the first puzzle will be, we'll turn it around. I don't know if it's the first one, but the next one I can think of is, what if the central angle is 62? The inscribed angle is half of 62. Well, actually, that's the first idea. Turn it the other way, what if the inscribed angle is 31? Well, you double it to get the central angle. So central angle, larger in the middle, inscribed angle, smaller out here. How much smaller? Exactly half as small. So let's do some IXLs. First, we can get our first 10 points here by, oh, hey, what happened? Okay, I don't know what happened. I logged myself out or something. So, but what is it? The inscribed angle is half. So to get that central angle, I double it. Excellent, 10 points up. RQS, well, RQS is the inscribed angle. What have we just learned about inscribed angles? They are half the central angle. 110 divided by 2. Boom, we're up to 19 points. Oh, okay, so you're saying that all the problems are not the same? Well, that's good. That'd be boring if they were. So first, look, what are they asking for? IHJ. IHJ. Hello. That's this angle right here. IHJ is right there, right? Well, we could solve that if we knew this arc. And follow the logic here. We need that arc in order to give us this angle. In order to get this arc, we need angle K. So what is angle K? What do we know about circles? 360 degrees. Well, all these central angles also add up to 360 degrees. So you can get out your calculator. I'll get out mine. And let's say that, I don't know who. I was about to say mom. My mom never gave me $360. Let's say someone gives the prize patrol gives you $360, but there are 3 people that have to share it. The first person spends 134 of those dollars, leaving 226, and then someone else spends 108. How much is left for poor kid K here? 118. So K is 118. 118, and that means this is 118. But they didn't ask for those, right? We were just using this as stepping stones to get to IHJ. So we take that number, I'm going to bring the calculator back, and divide by 2. So a lot of these problems, the last step, you're either doubling to get the big angle in the middle, or cutting in half in this case to get the inscribed angle. 59. And just like that, we have 28 points. Okay, 76 degrees, what are we looking for? We're looking for the smaller inscribed angle here. Just follow the letters, UWV. Well, if it's 76, cut it in half. I believe that's 38. You got it. Okay, let's take a look at this type. Okay, and this is where we get to the real point of math class. You've been given a couple tools here. You know a few things. You just learned one new thing, that the inscribed angle is half a central angle. And now put your brain to the test to see if you could solve for JIK. JIK. But Mr. Ekstrom, it's Friday. I don't want to use a brain. My brain or anybody else's brain. Well, it's only for a little while. So again, we're looking for this opposite, they don't call it opposite, they call it intercepted arc. They didn't give it to us. That was rude. Well, if, whatever mysterious measure that is, it's the same as this central angle. And here's something you know, right? So apply something that you've already learned. What do you know about a linear pair? And by the way, it is the same thing as the fact of a semicircle. How many degrees, inside or out? This is 180 degrees, right? And then here, this is 180 degrees. So we just take the 180 minus the 84, and you'll get your x. What's that, 96? So if x is 96, that means now that the central angle is 96. This arc out here is 96. And what do we know about inscribed angles? They are half the central angle, or half their intercepted arc. So half of 100 would be 50, and this is 48. Let's try that out. Okay, and we've seen this. We're going to complete the circle here. You'll find out that that's 141 degrees. Oh, it's odd. Is it okay to cut an odd angle in half? Sure it is. So instead of 140 becoming 70, it's 141 being 70.5. So, and there's a hint. It says enter your answer, integer or decimal. So you know the decimals are okay. Excellent. Okay, we've already seen this kind, so I'm not going to spend a lot of time. I will say it out loud, though. This supplement here is 95, and we're going to take half of that to get the inscribed angle. What's half of 95? Well, let's see. Half of 95. It's not 45. Half of, oh geez, let's get out the calculator. Half of 95. Everyone knows it's 37 and a half. Like I said, 47 and a half. No, I didn't. Okay, this is not getting harder yet. I want to get to a new kind of problem. Okay, I found one I like. Here we have, well, what do we have here? They're asking for EDF. EDF is over here. And so we would use this arc to help solve for that angle. And they didn't give it to us. So how are we going to solve that? Well, we have this one thing we know. If the inscribed angle over here is 45, then you know this is 90 degrees of the circle. Does that look like a quarter of the circle? Because it should. And guess what? Since that's the center, this is 180 degrees. That is a semicircle. So what's the red? It's also 90 degrees. So now we know we have 90 degrees of arc. They did not tell us that the central angle here was 90 degrees. We had to solve that. But, oh, hey, and that's what we were looking for, EDF. So let's put that in. 90 degrees. That's right. And then you knew it was going to happen. They were going to give you some algebra. just, well, let's take a screenshot of this and write on it. Okay, so there's no need to be afraid of a little algebra. But what do we know here? Let's go back to the beginning of the video. No, let's not. But what did I say? Raise your hand if you can remember what I said in the beginning of the video. The inscribed angle equals half the central angle. Well, that is what's going to help us solve this. Let's put this to the test. We've got the inscribed angle here. The 7x plus 5 equals half. So we're just putting the rule into math language, turning English words into numbers here. And you know what? You could distribute that half. That's going to get really messy. Who wants to take half of 17? Not me. So here's a tip. Take some advice from your math teacher. If you see a half and it's not nice and even over here, just get rid of the half by multiplying both by 2. Okay, so we're going to multiply that times 2. We're going to multiply this whole thing times 2. And why would I do that? Because 1/2 times 2 cancels out to an invisible 1. And now we have to double this, so distribute the 2. This is 14x. We've taken our inscribed angle and we've doubled it. And it is the same size now as the central angle. So one of these had to change. You either had to cut the right side in half, or you had to double the left side. And if it's even in here in the red parentheses here, then go ahead and distribute the half. Just do whatever's easier. And now we need to carefully balance this equation. So subtract 14x from both sides. And what are we going to do? We want this to be by itself. So we'll subtract 6. Are you kidding me? Is this going to equal what I think it's going to equal? So these guys cancel out. This becomes a 3. This becomes 3x. And yes, divide by 3. And x equals 1. Very sneaky. Now, if you type in the number 1, you're going to get the answer wrong. Why? Because x equals 1. They're asking for EGF. EGF, we're going to plug in that 1. You get 7 plus 35. I believe 7 plus 35 is 42. And we are correct. You are correct. 36. Does 4x equal 36? No, 4x equals 72. So we're solving for x here. 72, that would be, cut it down to 36, which cuts down to 18. Okay, and then here's a new kind we need to see, especially to get to 80. Just before you get to 80, they throw one of these at you. So what is going on here? They didn't give us a central angle. As a matter of fact, there's no central angle drawn. But what do we have? We could solve 14x if we knew this arc. Right? Let's call this arc. I don't know why I put it in black. We'll call it y. So we've already used x. Well, we know that this equals half y, right? But what about this angle over here? This angle, hey, guess what? It's also intercepting y, so this angle equals half of whatever that measure y is. So it turns out we don't need to know what y is. We just know that these guys are congruent. So without getting fancy and using a word like theorem or inscribed angle theorem, we can say if two inscribed angles intercept the same arc, then they have to be the same measure. They are congruent angles. And in algebraic terms, that means we can go ahead and just set the red one. Oh, let's use the color coding. We have all this nice color. Let's use it. So this red one equals the black one. So if you see two inscribed angles intercepting the same arc, and another one that makes sense is if they were just two different but equal arcs. In that case, they would have to give you what y is. See, here y is a mystery. We don't know what it is. We just know basically reflexive property. Y for the red angle is y for the black angle. Y does not change. Y equals itself. Let's not get too theoretical. Let's just do the algebra here. So subtract one of these x's from both sides. You get 39 equals 13x, and that's convenient because 13 goes into 39 beautifully. Okay, did they ask for x or did they ask for an angle? Always good to check. Yes, they actually asked for x, and we are done.